Hi friend, this is the fourth lecture that we are coming. Actually last lecture I have told you what is the concept of that discrete random variables, what is the concept of continuous random variables, and how the Venn diagram is useful to represent one equally likely cases or the cases in which the events are interrelated to each other. Now in the last case what you can see, we have come to the point that we will be getting three cumulative points, that is P1, P2 of 3 and P4, and they are not having same size of peak. Now to get rid of from the problem, again categorize the problem by considering the cases as PHH, PHT, PTH and PTT. We are going to that CDF, again I am saying. Now they are cumulatively, so as we can write that P of HH equals to X of S1. Okay, here you can see that P of HH equals to this P of HH union P of HT, that is X of 2, P of HH, P of HT, P of TH, that is X of 3, and P of HH, P of HT, P of TH and P of TT, that is X4. So here these four values you can see I have taken in a different way. One case where you have considered only one event, that is either head or head, no tail, that is P of HH. So you are tossing twice and each time you are getting head. So this particular event is X of S1, capital X of S1. The second event where we have obtained P of HH and P of HT. So the first one is H, the second one is H, the first one is H and second one is tail. So this event is P of HH and P of HT are union to each other, getting that new random variables capital X of S2. The third point we have taken 3-1, that P of HH, P of HT and P of TH. So in these three cases at least one head you can see, for the first case, for the second case, for the third case. So it is P of X3, and the last one is summation or the union of all the different probability point after tossing twice, that is P of HH union P of HT union P of TH union P of TT. So these all union value if summed together it will be giving that new value of X of S4. Now here I have defined them individually, as you can see that here X of S1, it means only one head or only head come twice from two trial. Okay, so what is the second case? X of S2, you can see that X of S2 is at least one head come from two trial, so which are mutually exclusive event, HH and HT. Now point number 3, at least one head come from two consecutive trial which are mutually exclusive or equally likely events, because TT, TH and HT, they are obviously mutually exclusive and equally likely cases, because TH and HT are equally likely cases, so obviously it is a mixed trial. Okay, and X4, this one, it means either head or tail comes alternatively. So here fourth point are being created. This is only one head can come, at least one head come from two trials, at least one head come from two trials which is having not only the mutually exclusive case, with that mutually exclusive case which have that equally likely cases too. Okay, now that equally likely cases, the mutually exclusive cases, only once come if all these probable results are summed up. So obviously we will be getting that P of HH union P of HT union P of TH union P of TT, all the probable cases. So what is the associated probability? That P of HH is 1/4, P of HT is also 1/4, P of TH is also 1/4, as they are the equally likely cases, so we can write that is half, So P of tt is also 1/4. So 1/4 plus 1/4 by 1/4 plus 1/2 plus 1/4. If you are summing them all up, it will be giving the final value as what? 1. So the x of S4 is having all total 1. So what is the value of x of S3? That is HT, TH. So it is 1/4, 1/4, 1/4. It is 3/4. Okay. So what is the value of x of S2? That is 1/4 plus 1/4. So it is 2/4. And it is only 1/4. So I can write the values. Therefore, here it is 1/4. Here it is 2/4. Here it is 3/4. And here it is 4/4. So these 4 steps are there. This one, this one, this one, and this one. Okay. These 4 values are being obtained from this 4 character. Now see what happens next. So finally we are having one trial rule as I equals to 1, 2, 3, 4 in this way. So we can plot it in this way, that for I equals to 1 we can place that first one, this one. It means this particular value x1. Okay. The second value is 2/4. The third value is 3/4, and the fourth value is 4/4. We are plotting them accordingly. So what we will be getting as this one is x of S1, and for this value, this one, it is representing x of S2, and this is representing as x of S3, and this is representing as x of S4. Okay. So in this way you are representing the graph. Okay. And we can plot the result in this way. For I different value as coming from 1 to infinity, we are having separate set of points like this. So these are representing in the form of step function, that you can see it is a form of the step function. So this can be interpreted mathematically in form of PMF as P, here x, capital X, less than equals to xi, because the value 1/4 for RV1 can be more or less as number of trial increases. Very important point to see here. So what is PMF? That is mass function. If you are considering individually, this is the PMF, this is the PMF, this is the PMF, and this is the PMF, if you are considering discretely. But if you are considering continuously, so these values are interrelated. So obviously we can write not Px equals to x, here P of capital X less than equals to small xi. So why I have written this? Because as the number I is coming to more, that is 5, 6, 7, 8 more trials, if you are having more trials, if you are involving, so obviously from the 2 consecutive trial the number of getting head is 1/4. For 1 consecutive trial the number of head is getting probability is 1/2. For the 2 consecutive case 1/2 into 1/2. For 3 consecutive case that is 1/2 into 1/2 into 1/2. In this way, as long as I increases, the value that 1/4 which I have assigned 1 will be more or less. So it never touches that particular value of given x. So that value is always less than equal to xi. So if xi is currently is 1/4, so the next value will be much less than this, the next value will be much less than this. So as I going from 0 to infinity, the xi will be much more down than the previous one. So here what you have considered, you can see that because of that value 1/4, the random variables 1 can be more or less as the number of trial increases. So here it is called that cumulative distribution function or the CDF. Okay, so in this way one CDF is one cumulative distribution function where we consider each and every discrete cases as the interrelated one. So we call that cumulative distribution function or CDF denoted as f of x is p of capital X less than equals to small x, and here f of x x1 is greater than equals to f of x x2 is greater than f of x of x3. For what reason? If x1 is greater than x2, so obviously that cumulative distribution function f of x of x1 must be greater than equals to f of x of x2, and hence if you are summing all this individual result as p1 p2 p3 up to pn for x going to infinity, that is equals to 1 for x equals to infinity, and it becomes a true set. And else x equals to minus infinity, so f of x minus infinity equals to 0. Okay, so f of x plus infinity, f of x minus infinity is touching the boundary of 1 and 0. So obviously the cumulative distribution function, the values must lie between the range of 0 to 1, as we have discussed in that PMF also. But here the fact is that PMF is only for the discrete values, the CDF is for that continuous RV we are considering here. Beside the continuous and discrete RV, means the random variables, there is another RV called as the complex random variables. Here can be represented as x plus jy terms. So x and y both are the real values are random variables and treated as another phase of this. So here we have come to a new function that is called the probability density function. Okay, what is CDF? That's distribution function, that is cumulative distribution function, which is coming from PMF for the consideration changes discrete to continuous. Here the new term has come, that is called the probability density function. So what is the density function? So the density means for x1 to x2, if you are increasing x, okay, a little bit delta, if you are increasing x a little bit delta, the CDF distribution function, it means the CDF is being changed, a CDF having some different value. So if x1 and x2, two considered point on that CDF scale, we are having say for example we can write it in this way. Suppose this is a graph. Okay, so this is a first CDF point, that is x1, that is the second CDF point, suppose this is x2. So in between x1 and x2, the graph, if it is increasing, so obviously the derivative exists. So we can say that is a maximum value and minimum value we have considered previously in our older classes, that probably 9, 10, 11, 12 we have considered this. So if you are increasing the nature of that curve, so what are the parameters to be measured? The eccentricity, the nature of increasing or decreasing, right? Else, so if the derivative is positive, it means the gradient of tangent is positive. It means that P df, if you are considering that probability density function, so obviously the probability density function shows some upcoming nature. Why? Because x1 greater than x2, and we have already known that f of x1 is greater than f of x2. Okay, in this way we can consider. So therefore, as we know from the concept of derivative, it is a gradient of tangent of a function for x and expressed as limit h tends to 0, f of x plus h minus fx divided by h equals to f dot x, or that is f dot x is limit delta x tends to 0, delta y by delta x, whereas that delta y is giving that error, that particular error. Okay, so here that the limiting value when arrived, it is basically f dot x plus epsilon, that limit value. When that error final comes as epsilon goes to 0, it is comes to the derivable value. So if we are considering that ddx of y, it is f dot x. So f dot x integral equals to fx plus c, where that c is called the integral constant. In this way, if you can write in this way, so the integration of fx is gx, we can say. So if you are integrating fx in that range of x1 to x2, it will giving that gx2 minus gx1 plus c, as c equals to 0. So it is a common ideas of taking derivative and the integrals. So here the probability density function is written as small fx, that CDF is written as capital Fx, thus probability density function is written as small fx, and cumulative density function is, sorry, it is distribution function, I wrote it wrongly, if you correct it, the cumulative distribution function is written as f of x of x. So the density function of x is a finite value ranges of Rv of x, and in terms of fx it can be written as p of capital X less than equals to small x. This is called the probability mass distribution function, and that is cumulative distribution function. So this is not density, it is distribution. So it is distribution. Okay. So here that property is 1, it obviously fall in that range of 0 to 1. So therefore we can have that the probability is what p of f of x integrating minus infinity to plus infinity, it is f infinity plus f infinity minus. F infinity plus means it is a true set, and f infinity minus means it is a null set. So the null set is 0 and true set is 1, so final value is 1. So that accordingly to that f of x is lying between 0 to 1. In the same way that p of x, or that f of x where f is a small x, which is a density function, it is also lying in the same range. So here f of x dx here is fx less than equals to 1 and greater than equals to 0. So obviously this particular value is falling that same range what I have told you now, and the area under the curve is 1. So finally all the sample points, if sum together, it will give the sample space. And what is the dimension of the sample space? It is always 1. Okay, the summation of all si I equals to 1 to n or k is 1. So therefore it is monotonously increasing in nature. So if f of x x2 is greater than f of x x1, so obviously x2 greater than x1, so obviously it is monotonously increasing in nature. It should be the property of that PDF and also have that particular value which I have discussed under 1, that it must fall in that range of 0 to 1. So that's all for the today's class. So that is the ending of the 4th lecture. So see that 5th lecture, more detailed discussion on that probability and the random variables will be there. So thank you very much for attending this class, and see you all next in my next class. Thank you.